Hello and welcome to another tutorial. We are going to continue our discussion about more on classes, and now we're getting to the this keyword. And we've already talked about this keyword a lot in the past, but let's have a formal look at this concept. Within an instance method or a constructor, this is a reference. Remember, this is a keyword. And if you're more familiar with the details of other programming languages like C++, you know that this is actually a pointer to the current object, right? The object, the context of the object that you're talking about. As long as you're physically within the scope of your class, this is a pointer or a reference in terms of Java lingo, is a reference to the current object. And sometimes you need to use it to explicitly tell the compiler to differentiate between variables, and that the main use of this keyword or this pointer is differentiating between local variables or fields or member variables if they have the same name, because we saw that whenever you have local variables of the parameters of a method that have the same name as the fields or member variables of a class, then you can't really in the constructor write a equals a, for example, or let's say the constructor takes x and y and then your fields are also x and y. So the way you are going to distinguish between this x, which is a local variable or a local parameter on the stack frame of this method, and this x, which is the field, is to use the this keyword. So you qualify x and y on the left hand side with this, and this means we're talking about the x which is part of the state of this object, right? This class. Or basically this tells the compiler, hey, look for this x outside the scope of the local scope of the method, and then it goes and searches for the global scope. In this case it's the scope of the class, right? Because there is no global scope outside the scope of a class in Java. So it's very easy for the compiler to realize that, hey, this x here means look at the scope of this class instead of the scope of the method itself, right? This just means, okay, jump out of the scope of the method and look at the scope of this class. All right, the object whose method or constructor is being called. You can refer to any member of the current object from within an instance method or a constructor by using this. Remember, when we say object here, it's actually when we are inside the scope of the class. So it's more about the class, but an instance of that class. Using this with a field. The most common reason for using the this keyword is because a field is shadowed by a method or a constructor parameter. And we saw this in the past, that local variables or parameters of a method can shadow global variables, and global variables means variables in the scope of the class. And in order to distinguish them, we qualify the global variables or the fields of the class with a this keyword. Using for example, the point class was written like this, right? The constructor takes a and b, but we said that this is not a good practice. It's better to have the same names as x and y as the fields, because then it's just very obvious what's going on. But then in order to resolve the issue of shadowing, because if you just write x equals x, both of them, the compiler assumes that they're both referring to these local parameters. So we have to qualify the left hand side with some extra information so that the compiler knows what we're talking about. Each argument to the constructor shadows one of the object's fields. Inside the constructor, x is a local copy of the constructor's first argument. To refer to the point field x, to refer to this x, which is part of the state of this class, the constructor must use this dot x, right? So we tell the compiler here, this x is actually don't look for this x in the scope of the method. Instead, search for this x in the global scope of this class, and then the compiler looks for this in the scope of this class, right? Obviously, when we jump out of the scope of the method, the local parameters are not visible. So the compiler, when we say this.x, the compiler searches for a variable named x in the scope of this class. Hence, this makes more sense. If you're familiar with the C++ also, so in C++ and Java, the idea here is that this is a pointer or a reference that is implicitly passed to the method or constructors. What this means is that this method is actually taking 3 parameters in reality. One of them is the pointer, this, right? That's why static methods don't take this, right? Because static methods are not concerned with the state of of the object. Now the question is, what if a static method takes a parameter and then its shadows and the parameter has the same name as the static field of the class? Then what are we going to do? And then we have to qualify that again. But then the way we qualify the static, first of all, in the static method, we don't have access to this keyword, right? So we have to qualify it somehow in other ways. So let's do this and give you an example. This keyword. All right, let's have a main method. So this keyword. So we have this class, and let's say it has int x. Let's initialize them. Int y is 2. And then let's have a public constructor, this keyword, and we're going to get int x and int y. And obviously in the constructor, remember constructors, this is one of the facts of Java. The fact is that constructors are never static, or can never have a static context, can never be a static. What this means is that in the constructor, you should always have access to the pointer to the class, right? Because you want to instantiate it, right? Basically, you have to be able, the whole point of the constructor is to be able to initialize the state, the non-static state, or even the static part, doesn't matter. You want to be able to access the non-static state of the object and initialize it and return a pointer to the currently created object, right? The object, the memory that we allocated in Java heap. So this has to be accessible inside the constructor. That's a fact of life about Java. And later on, if you study my course about Java native interface, this concept becomes more apparent. Why constructors are never static. When you want to invoke a constructor, you always invoke it in a non-static way, right? That's the fact of life. And obviously I cannot write x equals x, y equals y, and Eclipse's compiler immediately gives me a warning. The assignment to variable x has no effect, because again, I mentioned this before, the color coding on your IDE helps a lot, because the fields are blue but the local variables are brown, and it immediately tells me that the compiler inferred that both x on the left and right side are referring to this local variable, and that's not what I want. So the way we demystify this, or tell the compiler, we have to tell the compiler more information, and then we use this, right? And again, if you're familiar with C++, in general, this is a pointer. And then in C++, we kind of write this arrow, x, for example, right? Or in C++, we can dereference the pointer first, saying that start this, which means return the reference to the object, and then use the dot operator, right? So in C++, we kind of like write this. In Java, again, references are handicap pointers, and we don't see this star, because most people, when see this star asterisk operator, they freak out. That's why in Java they decided to hide this asterisk dereferencing stuff. Everything is a reference. All right, but then we said that in a non-static method, what are we going to do? Public do something, and then int x, int y, right? And again, it's the same idea as the constructor, and let's say this is void. It's the same idea as the constructor, because again, constructors are exactly similar to non-static methods. So all the rules that apply to the non-static methods also apply to constructor. Or maybe set x, let's have setters, right? So set x, we want to mutate the object, so this dot x equals x. Obviously, I cannot write x equals x, because both will be inferred as local variables. But what if we have a static method? What if we have a static method, right? What are we going to do then? Because remember, in a static context, this is not available. We don't have access to this, because a static method does not concern with the state. So let's declare a static. So let's say a static int z equals 3. We can initialize it, no problem, right? We have access to the static method. We have access to static fields and methods in the constructor, because a static state, although it's not concerned with a particular instance of the class, all instances have that state, right? So a static state is part of the state of each object, but it's shared amongst all of them. And we saw that when we use the new operator to create an instance of this class, the amount of memory that is allocated on the Java heap, what the new operator does, it only allocates for the non-static part, because the static part of the state of the class is saved, is created and saved somewhere else in the Java heap. And that happens when the JVM, so this happens the first time JVM loads the .class file into memory. Because when JVM loads, whenever you want to create an instance of a particular class, first JVM has to search for this class file, because JVM is lazy, and then it loads it into memory to understand what this type is, right? Because all the information about this type, an object of, for example, this keyword is a class, or it defines the type, is encoded in the class file, right? It tells the JVM what fields it has, what's the type, how much memory it needs, etc. It also tells JVM what is the static state of this type. And JVM loads this class into memory, initializes the field to the default values, and then it allocates extra memory for the static state of the type, and then it stores them somewhere in the Java heap. And whenever you create a use the new operator to create an object of this state, pass parameters to the constructor, the JVM initializes, basically JVM executes, JVM allocates memory on the Java heap for the non-static part of the state of the object, but then points the static part to whatever it has already stored somewhere in the memory, right? So a separate value, a separate piece of memory dedicated to the static state of the types. All the instances, all the objects that we create of the same type, they share the same static state. That's the whole idea. And in a first of all, in a non-static context, we have access to the static context, because a static state is still part of the state of each instance. So in the constructor, we have access to it. We can say z equals x plus y, for example. That's allowed, but we cannot qualify. I think let's see if we can qualify this. Yes. So we still can qualify z with this, because it's still part of the state of the class. So we have and we are in a non-static context. Remember, constructors are always non-static context. They can never be static, because they have to access the non-static state of the object. But then you see the compiler is giving me a warning, is that the static field this keyword.z should be accessed in a static way. And what it means is that, hey, you're saying that this line is misleading. So writing something like this.z is misleading, because z is in fact doesn't belong to this particular object. Remember, when we are in the constructor, when we say this, it means this particular instance of this type. Z doesn't belong to just this object, it belongs to all the objects, it belongs to the class, so it's shared. If you say this.z equals this, any other instance that I create, they're also going to change z, so they all see this change, right? So the compiler is just giving me a warning. And remember, this is not a compiler error, because a static field is still part of the state of each object, but it's shared amongst all of them. If one of them changes, the static part, everybody else sees that, because everybody is shared amongst all of them, right? Now, same with the non-static method. Non-static method is still a non-static context. We have access to the static state of the object in a non-static context, right? Z equals let's say 2x. This works. We can still write this.z. That's fine. But what if the name this was actually z? What are we going to do? So let's say this.x equals z. And then if I write z equals z, for example, this is not going to work, right? So what are we going to do? If we write this.z, this is going to work. But the compiler is still giving me a warning that you shouldn't really be using this, because z is not really concerned with the non-state of a particular object. So we have to qualify we have to qualify static fields with the name of the class, with the type itself. So in reality, instead of saying this.z, we should say the type. So we should say something like fully qualified name dot z equals something, right? And again, because we are already in the class itself and we want to access itself, so there is no need to use fully qualified name because we're accessing the same type. So we just say this keyword dot z equals z. So you access the static part with the class itself, and then you don't get a compiler warning because, again, this just points to the current instance that we created using the constructor, right? So this is how we qualify static parts. Now, in a static method, you don't even have access to this. So again, you could, let's comment this and bring this back. In a non-static field, non-static method, we could do this. Note that because of the name of the variable, we can't just write z equals z, right? That's the problem that we have. The first solution is to use this, but then this approach doesn't work in a static context. So public static void, note that set x int z, this is not going to work. This is not a valid overload because the modifiers don't matter, only the name of the method. Even the return type doesn't matter. So if I just say int, first of all, I get a compiler warning because this has to return something. But even before the compiler notices that the return is missing, it just tells me that there is a duplicate method because compiler just looks at the signature of the method. The name of the parameters even doesn't matter, right? Only the signature matters. You cannot overload based on the name of the parameters. You can overload based on the type. So I'm gonna say y, for example, int z, right? Let's set it to void. And again, we can say y equals z. That's fine. And then first of all, we cannot do this, right? I mean, I just said this is not correct because y is a non-static member. So let's say we want to set a z value, which is, we know that z is a static member, right? So we cannot say z equals z, right? If we change this name in the source code, then we say z equals x, no problem, everybody happy. So this is the easiest solution. But let's say we want to make sure that somebody, if they look at the source code, they know that this is the name of this parameter is also z, right? Then we make problem for ourselves because then the question is, how do we go about setting z equals z, because this z was a global variable in the scope of the class, this z is a local parameter. So we have to qualify it. We cannot say this equals z. And know that now I'm not even getting a warning. Now I'm getting a compiler error. Why? Because we don't have access to this pointer or keyword, this pointer in a static context. Right? Which means a static field, right? So we don't have access to this. If you look at the error, the compiler tells me cannot use this in a static context. So compiler is pretty much using the same wording that I used here, saying that, hey, we don't have access to let's see. I want to get rid of this message. All right, so the compiler is also telling us the same story. Okay, let's copy this error message. All right, cannot use this, which means this keyword in a static context. So what is the solution? To qualify the static with the class itself, right? So we're going to say that the fully qualified name, which is the package hierarchy dot this keyword dot z, we access the static part with the class itself equals z. This is correct, but we said that because we are already in the same type and we want to access the same type, so there is no point for the package. We don't need to use a fully qualified name, because when we are already inside the type, inside the class, and we want to access the same type, the same class, so we never do that, right? I mean, we can use a fully qualified name for like this keyword type, but it's not necessary. This is one of the rare exceptions that if you watch my previous lectures, I always say that be careful about the concept of fully qualified name. This is one of the rare places that I say actually don't use fully qualified name. It's not necessary, and it just makes your code less readable and more complicated. The reason is that in the bytecode, basically the compiler will substitute this line with the fully qualified name, right? Because JVM only understands fully qualified name. And again, as long as we are in the same type and we want to access the type itself, there is no import keyword. There is nothing like that because it's the same type, right? So there is no ambiguity for the compiler or JVM to where to find this type. Because whenever the compiler or the JVM reaches this code, it means they already have knowledge of the type itself, right? So in order for the JVM to be able to call this method, it has to first load the class file associated with this. So JVM already has information of this type and knows where it is and what its properties are. So for this kind of accessing the static in the context of the class itself, don't use the fully qualified name. Now, this is not the case when you want to access the static state or static methods basically in a class in some other package, for example. So let's go to OOP, basically a static demo. Let's create the main method. So first of all, if you want to access a static stuff, you don't need to create an object, right? So you just say this keyword dot set z, for example, and then 5. So this is valid, and note that my ID automatically did the import. But if I don't do the import, I get a compiler error because I'm inside another package, and this type at the moment it's not inside the same package, so it's not visible. JVM and the Java compiler and the JVM, they don't know. Right now we're doing compilation, so Java compiler doesn't know where this type is. So we have to tell it it's in from the class path. We have to tell it in this package, and then this keyword. So if you want to access the static part, and if I make this z a public static, a public field, I can directly access it. And again, I have to tell the compiler which type I'm talking about, this keyword and z, right? And it's a public, and then we can, for example, do even a sysout on it and print it without we're modifying the static state of the object of not the object of the class itself, without creating any object, without calling any new operator, and this still works fine. So the takeaway is that this keyword is only limited to the non-static context, which means constructor and then non-static method. In a static method we cannot, in a non-static method we can still say this.z even though z is a static field, but in a static context we cannot say this. We don't have access to this. And if you look at the bytecode, you see that for non-static methods, the stack frame, the 0th location is always a pointer that is pointing to this. In a static method, the first location, the 0th location of the stack frame of the method doesn't push the this pointer, doesn't have the this pointer, because the this pointer is not implicitly passed to the static method. So that's how this keyword works. And again, we can use it with the constructor. Again, the most use case of this is in the constructors, because usually you want to pass the variables to the constructor that have the same name. That makes it easier to understand which parameters the first parameter is assigning to which field. And then usually in the non-static methods we don't use this again, but some people prefer it, so this becomes a style, a matter of a style, coding a style in the source code. In the bytecode it doesn't really matter, it just compiles to the bytecode, and the JVM, this pointer is always passed as the first argument to the non-static method. So this was the whole idea of this. I hope you have a good understanding. At some point we will come back and review the static concepts more, but for now you have to know how to qualify the static fields, for example, when you cannot use this keyword anymore. And that happens when you're in a static context. So please stay tuned, and I'll see you in the next one.